You're listening to Skeptoid. I'm Brian Dunning from Skeptoid.com. Eclipse Myths and Science. News of the Great American Eclipse in 2017 caused the internet to be choked with articles titled Eclipse Myths. I received scores of requests for a Skeptoid episode on eclipse myths, but I resisted, mainly because very few of those eclipse myths were very interesting. Yes, we all know that many ancient cultures had all kinds of folklore surrounding eclipses. Wolves chased the sun, bears took a bite out of the sun, gods got angry and obscured the sun, a demon tried to steal the sun and could be chased away by banging pots and pans together. Well, fear not, because we're not going to cover any of that territory today. It already comprises the bulk of the online content about the 2017 eclipse, and it's widely available if that's what you want to hear about. Rather, today, we're going to talk about the plausible eclipse myths, the ones that people actually do telephone the observatories to ask about. And we're going to follow those threads a step or two further to see if there's something new and interesting to be learned from each. One of my favorite eclipse myths is that looking at the sun during an eclipse might actually be more damaging to your eyes than looking directly at the sun on a normal day. This is one of the questions that observatories report people calling and asking about. The reason I say it's one of my favorites is because it's based on genuine scientific curiosity. Right or wrong, it's a beautiful thing when people are asking the right questions. The corona visible around the black disk of the moon is something many people will never see. It's an unfamiliar sight. We all know the sun produces harmful radiation. Well, might this unfamiliar manifestation be unusually harmful? Even though the light level will be lower, might there be higher than usual ultraviolet radiation? Searching through online forums like Quora, it turns out that a lot of people are asking sound questions like this, exactly as more people should. Well, the answer is no, which you might know already, but some of what follows you might not. Starting from the basics, experiencing an eclipse is no different than being in a shadow. You're protected from the sun's radiation, both visible and invisible. The eclipse creates a gigantic natural coronagraph, which is a type of telescope that puts a physical black dot in the picture to block out a light source, and thus allows us to see nearby dim objects that would otherwise be washed out. The moon acts as the black dot, and once the sun is obscured, its corona suddenly becomes visible. The corona is always there, but we can't see it during the day because it's washed out by the sun's much greater brightness. I even read one impressive question that asked about gravitational lensing, whether it might be the case that invisible ultraviolet radiation might be more susceptible to lensing than visible light, and thus give us a full dose of harmful UV while we're all staring up at the corona during totality with unprotected eyes. The answer to this is also no. All light of all wavelengths is affected the same by gravitational lensing. Light has no mass, so it's not like some wavelengths are heavier than others. So then, you might be tempted to ask, well then, how can any light be affected by gravitational lensing? And this brings us to one effect that will be observable during the eclipse. Those among you who have good telescopes and are experienced at taking photographs through their telescopes can use the eclipse to verify general relativity. That's what causes gravitational lensing. Gravity is not so much an actual force, so much as it is a geometric distortion of space and time. Gravitational lensing is one observable proof of it. Physicists were thrilled to have the chance to test it in 1919, only 4 years after Einstein first published his theory, and you can do the same in 2017, or at any other eclipse. Because of the sun's high gravity, or more accurately, because of the distortion in space-time caused by its great mass, light bends around it. When we see a distant star that's near the sun, it appears to be a little further away from the sun than it actually is. Of course, we don't normally see stars near the sun because the daytime sky is too bright, but when the eclipse provides us with a handy coronagraph, we can see them. If we photograph the stars near the eclipsed sun, and compare that photograph with those same stars during the regular night sky when the sun is not nearby, we can see that the stars' positions are slightly shifted. And that is proof of general relativity. Well, how far shifted are they? Not very much. Not enough that you could tell without really good photographs and close examination. The deflection of the stars closest to the sun is only about 1/1800th the diameter of the sun, exactly as predicted by Einstein's equations, and exactly as confirmed experimentally during eclipses. It's not a very impressive visual display, but it's still mind-blowing from a physics perspective. And here's a fun little trick I use to help me remember which one is general relativity and which one is special relativity. General has a G for gravity, and special has an S for speed. General describes relativistic effects related to gravity, and special describes relativistic effects related to speed. An interesting tidbit is that Earth just happens to be the only known planet where the sun and the moon are the same apparent size in the sky, making this experiment possible. But even that's not every time. The moon has to be at perigee, closest to the Earth. When it's at apogee, we get what's called an annular eclipse, the so-called ring of fire, which leaves just enough of the sun uncovered that if you didn't know about it, you might not even notice that there was an eclipse. At least two of the more ancient eclipse myths have survived and continue to be talked about, or at least asked about, because they too sound like they might have some basis in science. One of these is the belief that leftover food, or food cooked during an eclipse, should be discarded. Whatever the origin of this might be, its modern-day longevity is due primarily to vague concerns about radiation. Is the food somehow contaminated by eclipse-related ultraviolet radiation, or something like that? Well, no, it's not, as we now know, because eclipses produce no such radiation or other effects, any more than an umbrella does. But even if they did, food, or anything else, would not be contaminated. I like to use the analogy of switching off the lights in a room. The room does not remain residually contaminated with light. People aren't generally afraid to enter a room that has recently had the lights on, and this is exactly the same reason they shouldn't be afraid to eat food that has recently been exposed to radiation. Once the light is switched off, the light radiation is gone. Same with the food and whatever its radiation source may have been. So again, we applaud them for asking the right question. The other one is the idea that eclipses are somehow harmful to pregnant mothers and small children, and that they should stay indoors. Although the origins of these beliefs can be traced back to ancient cultures like India, where they were associated with astrological superstitions, they get repeated often enough that overly cautious mothers might wonder if there is some actual cause for concern. The traditional Mexican belief is that eclipses can cause birth defects, and since birth defects are an actual thing in the real world, it's the kind of concern that does actually get passed around from mom to mom. Most who hear it don't know the source, and don't know if it might be science-based or not. Compounding the problem is that some who take the trouble to research it online are likely to encounter horrible advice like this, found on an Indian site called LifeCell. There is no scientific evidence to prove any of the myths about eclipses, but there also aren't any scientific studies conducted to disprove them. Do not object to every custom and belief because you do not believe them. Or this from an Indian site called Baby Center. If you or your family are concerned about the effects of an eclipse, there is no harm in following the customs. After all, it is just for a few hours, and if it offers you and your family peace of mind, it is probably worth it. No, it's not worth it. Seeing an eclipse is one of the great experiences you might ever be lucky enough to have. Don't encourage anyone to give the traditional superstitions preference. Now, I'm going to leave you not with an eclipse myth, but with a real unsolved eclipse mystery. Believe it or not, we don't know all there is to know about eclipses yet. In the final minute of light preceding totality, and again in the first minute of light after totality, you might see shimmering waves of shadow and light called shadow bands. Shadow bands are hard to see. You need a flat surface, white or light in color, facing the sun, at least a meter or so across, to be able to see them. They look like flickering, dancing zebra stripes, faint and delicate, and they do not always appear, so an element of luck may be required. So be lucky. Unlike the expertise and experience you'll need to prove general relativity with a telescope, just about anyone should be able to get some decent smartphone video of shadow bands, if conditions are right. Just put your phone on a tripod pointing at a white surface, switch the video camera to sports mode for fast shutter speeds, and look at the video later. Don't miss the eclipse. Nobody knows the complete explanation for what causes shadow bands, and they're not even fully characterized. They are believed to be atmospheric, in the same way that the atmosphere is what makes stars appear to twinkle in the night sky. It's also believed that the reason they only appear immediately before and after the totality of an eclipse is that it's the only time the sunlight is collimated to that degree, that is, the rays are so parallel. If you see shadow bands, look at the speed and direction of their movement, and their size and orientation. Are they aligned with the path of the sun, the path of the moon, or the direction of the wind? Which way do they move, and how do they change as the moment of totality approaches? So, there's a bunch of things to do and not to do, and to believe and not to believe, about eclipses. Whether the wolves and bears and demons and pots and pans figure into your plans is up to you, but for me, I'm going to stick to the solid science-based myths, and also to those who may not know the science yet but are willing to ask the right questions, and are eager to have the sun come back out to shine the light of knowledge. Skeptoid transcripts have at least two great uses. They include complete bibliographic references and further reading suggestions if you want to know more, and they also print out right from the web page as nicely formatted PDF documents suitable for sharing and printing. These docs are licensed for classroom use and also for annoying your woo-loving friends at the office. So that's a free resource for everyone, the transcripts for more than 575 Skeptoid episodes, all available at Skeptoid.com. Just search for any topic you can think of, and there's a handy-dandy cheat sheet for you. You're listening to Skeptoid, a listener-supported program. I'm Brian Dunning from Skeptoid.com.